Hello, Farmington High School. Mr. Hooper speaking. I got nothing funny to say, so we're just going to keep recording videos. Multiplying expressions, so multiplying radical expressions. I've actually been cheating a little bit. The way I've been teaching you perfect squares is basically how we're going to multiply radical expressions, except we're going to show you a few new tricks to go with it. So multiplying radical expressions, you're multiplying the outside, then underneath, and then simplifying. So I'll kind of show you what I mean by that. Pause if you need to write that down. So outside. So when they talk outside, they're talking about the ones that we don't write there. 1 times 1 is 1 times the square root. Inside the square root are 2 and 5. 2 times 5 is 10. Square root 10, we know that doesn't have anything it can reduce by. So what they're talking about is the outsides were the 1s, the inside were the 2 and 5, square root 10. So if I go over here, outsides 4 and 6, 4 times 6 is 24 times square root. So that's where they would probably write 3 times 2. And actually, if you wanted to, you could write 4 times 6 here. So I'd write 24 times the square root of 6. I actually know the square root of 6 cannot be simplified. Seems straightforward. You guys should do well with this. And then we got a few more difficult ones here. So what I would do is I'd probably look at this as 2 times 1 times 4 times square root 3 times 2 times 3. Now 2 times 4 is 8. Now the funny thing here is I can actually see a 3 here and a 3 here. Okay, so if you remember, 2 3's together can be written out front, so you could write this as times 3 times the square root of 2, which is 24 square root 2. Okay, the other thing I've been having you guys do is you could have wrote it as 8 times the square root of 18, which is 3 times 2 times 3 times together. Then you would have had square root 9 times the square root of 2, and then you would have had 8 times 3 square root 2, and 24 square root 2. So there's multiple ways to get there. The other thing you could do is maybe you're a calculator person. If you type that in your calculator, I'm trying to do 24 square root 2 in my head, you should get the same answer as if you typed 24 square root 2 in your calculator. I don't know what that is. 24. It should be around 25.8. It should equal 24 square root 2 as well. I just lied to you. Maybe. I don't know. We'll find out. Somebody check this and then tell me if my video is right. Alright, look at this. Negative 6 and 4. Negative 6 times 4 is negative 24. Square root 5 times 15 is 75. So all I've been doing it is negative 24 times the square root. I would have wrote 25 because 3/4 go into 75. And then I would have said negative 24 times 5 times square root 3. This is going to be negative 120 square root 3. Okay, and that's what you're looking for. So, slight confusion there. But if you want to type stuff in to your calculator, I can show you, and you could check your answer that way. Now remember that these numbers that don't end or don't repeat are numbers that are irrational. So 24 square root 2 is actually 33.9. So you should have got 33.9 when you, if you would have typed 2 square root 3 times square root 2 times 4 square root 3. That would be a way to check your answers, to make sure that both of these lines, the one answer you gave me plus the equation you started with, both equal that same decimal. And that's rounded. Remember, these are exact answers. These are all irrational numbers, but they're exact answers. Alright, so now if we finish these two on the bottom quick, now we have some numbers that I would consider with variables. That's what I was thinking. So 1 and 1 is 1. Square root, 20 times 6 is 120. X 2 and 1 is 3. Alright, so then if I tried this again, do any of the colors show up on this? Alright, I'd have 1. I don't need to write 1. So square root 120, I think I would go with 4 times 30, and then I probably would go x times x times x. Square root of 4, I'd pull out, is 2. We got these two x's here, so we can pull them out as an x. Then I'd have square root 30x. And that is actually your final answer. 30 has 5 and 6, 10 and 3, but nothing actually really goes into 30. So we would just leave that as 2x times 30x. Now looking at this one, I would have 18 and 4, or 1 and 4. So actually a 4 is out front. I'd have 18 times 3. That's going to be 54. And actually I would leave it if you wanted to. You're multiplying 18 and 3 together. Why don't you write 18 times 3? Because look at all these a's we got to write. Now, looking at that, 18, alright, I could probably split into a square root 9, square root 2 times 3, and then I'll leave these a's in here, times a, times a, times a, times a. Square root of 9 is 3. So 4 times 3 here is going to be 12. Alright. These two a's would come out. So I'd have a. Another 2 would be times a times square root 6. 2 times 3 there. So I think the best answer here is 12a squared times the square root of 6. Now I do make mistakes. Sometimes if you find them, let me know about them so I can redo some of these videos. Alright, now if you flip over to the back, number 7 is going to be the first opportunity that we have where we get to distribute. Alright, so square root 3 times square root 5 would be square root, 1 and 1 is 1, 3 times 5 is 15. Keep this minus sign, square root 3 times 4, 1 and 4 is 4, and then this is square root 3. I'm actually done right now. Right, there's nothing else I can do there. Right, square root of 15 doesn't really reduce. So negative 3 times 2 would be negative 6. I don't have a square root behind this, so square root of 3 is going to be the same. Negative and a positive is going to be a negative. It would stay 3, and this would be square root 18. Now we've done square root 18 a few times. Alright, that's going to be probably square root 9, square root 2. I like to write it as negative 6 square root 3 minus 6 square root 2. And that's incorrect. Alright. Square root 9 scribbled out is 3. 3 times 3 is 9 square root 2. Now this is like subtracting x and y here. Square root 3 and square root 2 don't go together, so you are done there. Then number 9. Okay. We got a bunch of stuff under the radical, so I would have wrote this as 3 square root 14x minus 1 times 1 is 1. So I just have everything under the square root. So probably a 2 times a 14 times an x, ooh, and another x. Alright, so I think this would be 3 square root 14x. The way I've been doing it, we could prime factorize this one. 2 times 2 times 7 times x times x. Right? Because instead of writing that 4, we could pull that 2 out there, and these x's out here, so this would be 2x square root 7, and then this would be 3 square root 14x minus. Final answer, folks. So that one doesn't really simplify very well, but I think it's pretty easy to show you how to get that final answer. And then number 10. Number 10 is a beautiful problem, because you have 1 times 5, so that's 5. Square root 5 times square root 2 is square root 10, minus 1 times 4 is 4. Square root 5 times 8 is 40. So now 5 square root 10 minus 4, and I would write square root 40 as square root 4 square root 10. That's how I do it, because I would have 5 square root 10 minus 4, square root of 4 is 2, so times 2 times square root of 10. 4 times 2 is 8. 5 minus 8 is negative 3, square root 10. So I was looking at my chops right away because I saw square root 10s were going to line up. So then I knew I could combine like terms and make that negative 3 square root 10. Alright, last two. And these are the important two. They're not important at all for us, per se. I think there might be one that's difficult on the test, but this is all of Algebra 2 here. Alright, this is pretty much exactly how Algebra 2 starts with their notes, is making sure that you understand how to multiply radical expressions so that you can do things. And this is a review of our favorite thing in the world called box method. I'd put a 3 here, a square root 5, a 3 here, a negative square root 5. Alright, 3 times 3 is 9. 3 square root 5, that should be common. This would be negative 3 square root 5. Small voice crack. This would be negative square root 25. And I like the way that looks. But 9 plus 3 square root 5 minus 3 square root 5 minus the square root of 25 is going to be just 5. Now, you should see these two cancel out. 3 minus 3 is 0. 0 times square root of 5 is 0. So 9 plus 0 minus 5, or 9 minus 5 is equal to 4. This is a beautiful problem. 4. Okay, let's try this again. There's two ways to do this one. Miss Johnson just multiplies all of them together. I would look at square root of 24, and I would probably write it as square root 4, square root 6, and write it as 2 square root 6. So I would reduce right away. So I probably would have put a 2 square root 6 here, and a square root 2. Then I would have put a square root 6 here, and now 8 is one of those 2 square root 2's as well. Right? So you take a 4 out, square root of 4 is 2. So I would have probably wrote 2 square root 2 here. Okay? You would have 2 times the square root of 36. You would have square root 1 times 1 is 1. You'd have square root 12 here. Here you'd have 2 times 2 is 4, square root 12. And then here you would have 2 times the square root of 4. Well, knowing a little bit of math, the square root of 36 is 6. 2 times 6 is 12. Square root 12 would probably stay the same for this purpose. Actually, it wouldn't, would it? So let's get that'll work. So this was a 6. 2 times 6 is 12. When I see a square root 12, I think square root 4, square root 3. So this would be 2 square root 3. So it's 12, square root of 12 is 2 square root 3. I could take my 2 here and multiply it by the 4, so I would have 8 square root 3. And then the square root of 4 is actually 2, so 2 times 2 is 4. So now what I see is 12 plus 2 square root 3 plus 8 square root 3 plus 4. I see 16 plus 10 square root 3, which is the exact same thing Miss Johnson has. We just kind of reduced, alright? If this is confusing, reducing inside of box method, don't do it. Alright? You have the choice to just multiply square root 24 and square root 6 together and things like that. You're going to get numbers like square root 144 and square root 192. And if you like that, that's okay. But you have decisions to make on your own. So what I would tell you is that should have been the easiest notes video. The only refresher you really needed was box method. If you have questions about the box method ones on your homework assignment, please, please, please ask. Otherwise, thanks for listening.